3D printing, and what actually as a mechanical engineer we are trying to come up with this. And the target area is the veterinary applications. Before my actual discussion in this area, some overview about our country and the present requirement. You know, in our country, this data that I am trying to show, just 2 3 slides, this I have taken from the NITTTR website. If you just see the NITTTR website, that is the Planning Commission of India, but what we will see that even there were numerous plans in our country that the GDP of the country should be, really good, and the manufacturing sector must contribute in the GDP of the country. But in past 30 years, this is stagnant to the 15%. That is one of the major problem. And if we compare our country with China, this contribution of the manufacturing sector in GDP is around 34%. And the problem is not new. A lot of efforts have been done, but still from past so many years, this problem is there. And what the website says, the Planning Commission of India, now called NITTTR, says there seems to be some policy failure. Actually, to overcome this, the Atmanirbhar Bharat concept has been there. Uh, in 2004, Government of India set up a National Manufacturing Competitive Council, which was headed by the group of ministers. And in 2006 itself, the Prime Minister of India at that time, he also put his concern that the contribution of the manufacturing sector must increase from 12 to 14% to 25 to 35%. And if I just Google the on the website, you will see that the target by Government of India for 2025 is around 25%, and still we are at 15%, right? So we need to do really hard to achieve this, right? If you just compare in past 10 years or past 20 years, the situation is not improving. And why we need this? If I am able to increase the contribution of the manufacturing sector from 15% to 25%, there will be 100 million jobs, specifically for the technocrat, right? So that is also one of the major concern in our country. Job scenario is really uh, alarming, and after this COVID period, a lot of things has to be improved. Even not only the government sector but also the private sector people, they are also focusing that we need to do this. Like one of the quote I have put by BHEL executive director and Ravi Chandra, he is also saying the similar things. Even some private sector people, they are also focusing on the same thing. Basically, we have to increase the contribution of the manufacturing sector. That is the concern. Manufacturing sector doesn't mean pure mechanical manufacturing. It may be the manufacturing of electronic goods. We are interested in developing some sensors. We are interested in developing various medical goods and so many things, right? But there are some issues in our country, like we have in infrastructure problem, we have the finance issues, we have the problem with the land acquisition, there are labor laws are there, and so many things are hanging in the parliament. A lot of resettlement bills, a lot of things are pending. Now, what does this mean? Whether we should stop working, or we can have something which can help us to come out of this situation. So to address this issue, there was a discussion among various stakeholders, and in one of the discussion between CII and government of Andhra, they come up with a very beautiful thing, that is the innovation in the product and the process should be the key driver for the growth in the manufacturing sector. Now, this innovation in a product and the process. Now, this is the basically key point for our discussion, from where we came up into the area of veterinary. If we are able to do this, there will be number of jobs, ample jobs for our countrymen, and this will help us to come up with a lion share in the market. Now, this is another data that I want to show you. As per the Thomson Reuters in 2014, it was published that the engineering contribution was by the country was 4.3% in 81, which was reduced to 2.2% in 1995, and further it was increased to 4.25% in 2010. If I see the current data, which is now by the Clarivate Analytics, it is still around 5%. That means for 95% of the research in engineering, we are dependent upon the Western world. But if we compare our data with China, Korea, Taiwan, they are doing much better than us. We normally say we are good in computer science or software development, but if we see the contribution, this is just 2.4%, whereas other countries, they are contributing much more. Now, why we are discussing this? After the National Education Policy 2020 has been launched, now there is a lot of opportunity to work in the area of multidisciplinary or interdisciplinary research. That is what is some tool or help by the regulatory bodies in our country to think out of box solution, which can be really innovative, which can help us in product development, which can help us in something in coming up with the idea of new product involving different disciplines of people, and then launching that product first in the market, so that it is having some marketability. Now, to fetch this, to come up with this, the 3D printing or the rapid prototyping is one of the tools. I understand that from last 1 or 2 days, uh, all of us are learning about the 3D printing, so the fundamentals are a bit clear. Uh, Broadly, if I talk about 3D printing or additive manufacturing, we classify this as a process that involves the technology which may be liquid based, that may involve a technology which may be a powder based, which may be semi solid based, or it may include some metal part also. So there can be one other classification in which we are working on polymers. There may be another classification we are working on metals. There may be another classification we are working on the biogels. Right now, just for the some of the beginners in this area, I just want to have this input that in 3D printing, basically, whether it is a plastic based, that is thermoplastic based, whether it is a metal based, or whether it is a biogel based, the basic idea is I am having some CAD data in some file format. That CAD data is fed to the 3D printer, which in this case is looking like a photocopier, and finally I am getting a 3D printed object. So this is a fabrication method where we are getting the physical objects which are constructed by depositing the material layer by layer, and there is a computer controlled, of course, which is of course virtual, and I am getting the final object in the physical space one after the another. This is another way of understanding the 3D printing. So I am putting the layer by layer successive, material which may be melted, partially melted on a build platform to get a 3D printed part. I think this is a very traditional definition, and a number of times we have seen this, that I am interested in building some part layer by layer. Now, this part may be of a polymer, this part may be in the form of biogels, this part may be in the form of metallic powder. The joining mechanism may use some adhesive, it may use some melting through some laser, or maybe some binding action, right? Now, if I am really interested in for medical applications, specifically for veterinary or for the human application, there is one additional step that is required. That is the basically the idea of the 4D printing. Basically, I am interested in some self-actuating type mechanism which can help me in the control growth of some part of the these type of 3D printed functional prototypes. So to understand this, what is basic about 4D printing? I am printing basically a smart material. Now, what is a smart material? Smart material is something which can change its physical state, maybe after solidification. Here, in this case, the solidification means is the 3D printed part, and once I give some stimulus to it, that material is basically changing its some of the properties, and those effect of the stimulus is reversible. Like giving some stimulus in some form, I am getting some controlled environment, and then if I am reversing the stimulus again, I am getting the repeatability. Now, to put my point is a in a more simplistic manner, I gave you one example. All of us have seen a sunflower. Now, sunflower always faces towards the sun. So once there is a sunrise, the sunflower moves up. So once there is a sunset, it faces down. And as there is a movement of the earth around the sun, so the sunflower also have a similar rotary movement, right? So that is what we are observing in nature. So that means there is one stimulus. The stimulus is the sunlight, which basically actuating some of the mechanism. Now, the taking the similar concept in typical mechanical application, we can think of developing some hard tissues, developing some implants. We can think of developing some self-actuating mechanism, which can be controlled through some stimulus. The stimulus may be in the form of light, the stimulus may be in the form of heat, the stimulus may be in the form of chemical energy, the stimulus may be in the form of temperature, the stimulus may be in the form of moisture, or there can be the combination of these type of the stimulus. I give one more example to put my point. All of us know, in a typical mechanical engineering environment, we are interested in measuring the cutting forces. So once I am interested in measuring the cutting forces, we use an instrument called dynamometer. So what is basically a dynamometer is, in dynamometer what we are having a quartz crystal. So if I put a load on a quartz crystal, its dimension increases. Now you release the load, it comes back to the original dimension. And if you do this loading and unloading n number of times, it will have the same repeatability. Right now, taking this type of behavior in some smart printed materials, like one of the example is the PVDF. This is there is a biocompatible grade of PVDF, right? If I put a load on a PVDF crystal, right, or I give a high voltage as a stimulus to this type of material, it changes its phase from alpha to beta. So once it changes its phase from alpha to beta, basically what I am expecting is there is a attraction, or or there is a compression, or there is a expansion. So using this property of phase changing alpha to beta, basically I can think of a transducer type application for some compaction or some expansion. So that is one of the widely explored phase changing material with a stimulus. There are normally two type of stimulus for this. One is the load, and second is the basically the voltage. Now, I give you one example to put my point. Suppose there is a veterinary patient. Let us take the example of some wild animal like a tiger or some lion is there. We are actually trying to develop some of these type of implants for these type of the wild animals. Now, suppose during poaching, there was some bullet injury to these type of the wild animals, right? And let us say the front leg of the veterinary patient is damaged, right? And what we observed, there is a crack in the front leg. Now once we have to go for the operation for these type of wild animals, we have to operate under the general anesthesia. This cannot be performed under local anesthesia because they are basically wild in nature, and you have to perform the whole surgery in a single sitting, and you cannot give the general anesthesia time and again, because it creates a lot of issues if I am giving the general anesthesia number of times. So what actually we do for these type of cases, we try to put some implant in which the PVDF crystal is embedded along with the implant, right? So that PVDF crystal, once the patient puts a load over it, right, we are able to observe what is the health of the patient. Now how it is, basically by developing a sensor that through 3D printing we put into the bone or the fractured part of the patient, right? Now this is through the 4D printing. Now, why it is 4D printing? I am putting a stimulus. The stimulus is load. Like for example, there is a patient, and I have putting an implant to overcome some, bullet injury in the bone part, right? Now, once the animal will put a load, basically the PVDF crystal will get actuated. So once it will be actuated, it will produce some charge. So once it will produce some charge, I am making a sensor. I am attaching it with the metallic part and the substrate part, which is a polymeric part, which is a 3D printed part, and this is going to generate some signal for me in the form of electromagnetic waves. And that data I am getting on the ISM band, basically on my Bluetooth range, right? And the ranger in that area will be understanding, okay, within this range, I am getting a peak on some, platform like VNA. Okay, this much gigahertz data I am getting, and finally we are able to basically see if the health is improving, then the peak or the curves that we are getting, there will be a shift in that. So that is the one of the smart way using IoT based solution with 3D printing for understanding the health of some of the wild animals, or these type of the veterinary patients, right? So what I can say, this 4D printing is an extension of the 3D printing, and any 3D printing becomes 4D once the another dimension is added as a function of time, right? So basically, I need a reversibility. So if I apply a load, I am getting some output. You reduce a load, again the another value of the output is coming. So if I do n number of times, like putting a load, releasing a load, putting a load, releasing a load, I will get a repeatability, right? So what can be the reason of this type of smart behavior? This can be the intrinsic property related with the internal property of the material, like self expansion and self contraction. Now I give one more example for this. Sometimes in some of the patients, what we observe with our surgeon collaborators, let us say there is a some orthopedic case in which one patient is of one length is shorter as compared to rest of the three legs, right? So what actually they do, they basically cut the leg, and in between we put a telescopic nail which can be actuated under the effect of magnetic field. So if I apply a magnetic field, that telescopic leg can be extended, and if I reverse the direction of the magnetic field, it can be contracted. So we can increase the length, we can decrease the length within, of course, the defined range. So that is one of the area where a lot of people are working. So here, self expansion and self contraction, maybe through some stimulus, maybe in the form of electric field, maybe in the form of magnetic field, people are working on this. Then sometimes we are interested in adding some property from the external side, so we call it as the extrinsic property. So once we talk about the extrinsic property, right, so here again, it can be through reinforcement. So there can be reinforced material, or it can be through metamaterials. Now, one of the common example is, suppose I am interested in getting some, electrical property, thermal conductivity or electrical conductivity in that type of the implant. So we can think of reinforcing with some, aluminum powder, some copper powder, or graphene powder, depending on the application, right? So I can do that thing. One of the recent concept in 3D printing is, specifically in the case of the bioprinting, is the use of the metamaterial type structure. Now, what is this metamaterial? To understand this metamaterial structure, we have to follow some of the civil engineering concept. Like for example, in a typical strength of material class, we used to learn about the concept of trusses in the railway bridges. So once we talk about that concept, we have a in a railway bridge, there are number of links, right? And the angle of the truss, that is important for reducing the section of the solid part, right? So in this case, what is important is the length of the link and the angle of the link. So if I am able to manage that thing, I can basically reduce the section of the railway bridge. Now similar concept, if I am interested in developing some of the hard tissues I am printing, and my job is to reduce its weight. Similar concept, once I am working on the printing of implant specifically for the veterinary patients or the human patients, its weight should be minimum. So we can think of using a this type of the metastructures. So in metastructure, again, the property that I am getting is not because of the inherent property of the material, but the length of the link and the angle of the link is really important to basically give the given property, right? So that is one of the really upcoming field. And then we can think of the programming of this type of smart materials. It can be one way, like your material is in state A, you give some stimulus, it is coming to the state B, again another stimulus, it will come to the state A. So this is a one way programming. Then there can be two way programming, like stimulus on, stimulus off. You can change the state, the stimulus, like in the example I have given for that telescopic leg, in the form of the magnetic field. Then it can be multi-stage programming, from A to A1 one stimulus, A1 to A2 another stimulus, then A2 to A3 or something like that, but it should be a closed loop. So that is really important in this type of the programming. Okay, now before I actually talk about the tissue reconstruction, one of the very low cost technology that is very commonly used is the fused deposition modeling. I think most of us know about this process, but let me just explain, because this is one of the cheapest technology, very cost effective technology, through which I can make some smart materials for the different type of tissue reconstruction. So what the idea over here is, I am having a spool of material, a thermoplastic material, which is basically fed to a zone. Here I am having a region where I can force this type of the feedstock filament, which is in the form of wire, through some mechanical drive, and it enters into the region which I am calling as the liquefier. And here there is a temperature range, maybe varying from 150 to 300, right? But people have worked on quite different range, maybe from 50 to 500 also, depending upon the application. And then here I have a nozzle through which this larger dia wire is basically coming out from this region as a very fine wire. So normally the input dia of the wire is 1.75 so so once it comes out, it is to the tune of 0.25 or sometimes zero point 0.1, this type of the dimension, right? So again, the wire feedstock filament forced into this liquefier zone through some mechanical drives. Here is the nozzle, and larger dia is converting into the finer dia. Then I can move this in XY platform. So layer by layer material deposition. So once there is a 3D printing of the part, this platform goes down and I get a final finished product. Now I have shown this because this is a typical thermoplastic based polymer 3D printing, and number of papers on this polymer 3D printing are there. But specifically, what is important is this is one of the very cost effective technique through which we can add uh, different type of reinforcement, specifically to get a extrinsic property for 4D application. And I can think of using this type of material for development of implant. I can think of using this type of reinforced material for the metastructure also. Okay, now here we start with the actual collaboration of mechanical engineering with the veterinary science. So what is the problem? So this is one of the first case study that I want to share with you in hard tissue printing. In this case, what we have done is we prepared a feedstock filament of polypropylene reinforced with calcium carbonate for hernia tissue reconstruction in case of the bovine. So bovine is basically a cows or buffaloes. These type of are called bovine. So we are interested in hernia tissue reconstruction. So that is a problem. So typically, if I talk about the hernia, this is the specifically for abdominal hernia. This is very crucial in veterinary patients, and specifically in case of the cows, their health is affected. Finally, the milk production is really affected. So in this part of our country, we are really interested in dairy farming. So a lot of people are working on these type of the animals, and this hernia is a very common problem for these type of the bovines, right? So the to control this, to solve this problem, polypropylene mesh in hernia treatment is a very common approach, right? But what we have observed from the literature, if I am reinforcing calcium carbonate, which is having a anti-inflammatory effects, this can be really useful in the treatment of hernia. And till now, no one has developed the mesh with the reinforcement of calcium carbonate and polypropylene, which can be really useful for the long term treatment of the hernia. So this will help in blood coagulation, and also help in the easy surgery of these type of the patient. So use of polypropylene calcium carbonate composite is one of the solution. I'm not saying this is the ultimate solution. Is one of the solution for the treatment of the abdominal hernia in case of the veterinary patient. And we since we know that 3D printing is one of the most flexible tool that can be used for the preparation of these type of the mesh structures. Now here we will come to know. So this is the typical example. Here there is a abdominal hernia in case of the cow. So what actually we do is we by surgery, the extended part, which is more or less a dead part, that is cut, right? And we put this type of the polypropylene mesh inside, and then we do the surgery. And finally, the with the outer skin, we are interested in doing the suture over here. And then we perform the what we observed that for these type of animals with the average life of 10 to 12 years, this polypropylene mesh, sometimes some people are also using polyamide also, but most common is polypropylene mesh is basically used. So what is our contribution right now as a 3D printing engineer is, if I can have this type of mesh which is 3D printed, and it consists of CaCO3 along with the polypropylene, the strength is greatly improved for this type of composite, number one. Second is if I'm using this type of the composite in which polypropylene and CaCO3 is there, the anti-inflammatory effect of CaCO3 help in controlling the hernia in a big way. So we were really interested to understand whether there is a novelty in this. So basically, we use the Web of Science database, and we put the keywords like polypropylene and calcium carbonate, and then the Web of Science database was put into the open source software that is called the WAS viewer, and we get this type of the bibliographic analysis in the form of networking diagram. So each color is representing a particular type of research work done in the form of different clusters. So we get, let us say, the four major clusters: red color, blue, yellow, and green, right? So we based on these clusters, we came to know that what sort of a research work has been done in past, and then we focused specifically on the polypropylene matrix. And then we come to know for the polypropylene, people have worked for the strength, people have worked on its DSC, people have worked on its SEM analysis, some TGA analysis, XRD analysis, FTIR analysis. These type of things have been done, but no work was reported on using this anti-inflammatory properties of calcium carbonate with the PP matrix. So we try to explore this. This is the flow chart. So collecting the podal, polypropylene and calcium carbonate, then checking its MFI. This is the basic rheological property. This we done as per ASTM D1238. Then making the samples, tensile samples as per ASTM D638 on the UTM. Then following some morphological analysis. Based on this analysis, we prepared the feedstock on a twin screw, perform the mechanical testing, SEM, FTIR, microscopic analysis, then some optimization on the screw extruder, feasibility of 3D printing, and finally, after the optimization, that polypropylene reinforced with calcium carbonate mesh has been provided. So these are some of the graphical representation. This is the composite. This is the feedstock filament. Some testing, and you can see some of the printing going on over here in the form of tensile coupons, compressive coupons, for flexible property. And then if I'm interested in under some torque, if it is there, that can also be created. So we use just the open source FDM based 3D printer to print this type of the composite. So these are some of the results of the mechanical testing in terms of stress strain diagram. So we try to observe there using some DOE in form of peak load, peak elongation, break elongation, peak strength, break strength, and then checking their porosity, their surface roughness, right? And these type of all, you know, uh, controlled condition as per the existing commercial solution we were able to provide. Now here are two important things to to be noted. One is I am interested in hernia tissue reconstruction. This is very common problem in case of these type of milking cows that we have a problem for managing the hernia, right? And the commercial available solution is polypropylene mesh with little or no support for anti-inflammatory property. So that has been added into the mesh of polypropylene in the form of CaCO3. Try to make its composite with the maximum allowable percentage, doing some in vitro and in vivo analysis, and based on that, preparation of the feedstock filament, preparation of the mesh as per the design as a customized solution. So what is the size of the tissue that we want to reconstruct, or that we want to cut, or remove in a systematic manner, and then printing, and then doing its porosity analysis, mechanical analysis, thermal analysis, morphological analysis, its surface finish. These type of things can be done. So this is the one part of 3D printing that can be used for the managing the hernia tissues. Now this is the another example, another case study. Here we are interested in uh, controlling or saving the hard tissues, the skin part, by using some advancement in the veterinary patient. In this case, it is canine. So canine is a species, specifically the dog family, for basically. Uh, for managing the bone fractures. So what is the standard procedure in this case is, you can see in this image, this is the X-ray image. This is a case of a 1 year old pit bull. So pit bull is basically one of the common breed that is used in the domestic application. A lot of people are interested in having these type of animals. You can see there is a fracture, right? There is a fracture. Now to solve this fracture, or we can have a number of solutions. I can put some plates from the outside, right? That can help me in healing the fracture. In case of the dogs, what important is, if the dog is 10 to 12 years of age, basically if I put a sport, or I put a pin, as you can see over here, this pin is called intermodularary pin. If I put these type of the intermodularary pins in case of the dogs, right, what will happen, uh, in 10 to 12 days I get a total healing if the age is less than 1 year. If the age of the dog is more, then maximum it will take 20 to 30 days. But even up to 6 to 7 years of age, the there is a complete healing of the bone for these type of dogs. And once this healing is over, what we are doing is we are removing these type of the pins, right? So this is very common practice. Let us say this is the portion from where I am inserting a pin. This is the proximal end, this is the other end, this is called the distal end. So basically for solving this type of the fracture situation, I am inserting a pin from the top, and this pin is going to the downside. So from the proximal side I am adding a pin, and on the other side it is going down, right? So let us have some basic understanding of this. Due to the excessive vehicular traffic, there are long bone fracture in dogs. If I talk about the literature, it is reported that oblique or the multiple fractures which are of unstable configuration, these are due to the vehicular trauma or maybe falling from some height, it is very common. So one of the solution is the intermodular nailing in case of the long bone fracture. So you can see this canal, inside canal is called the intermodular canal, and the putting a pin inside this is basically a intermodular nailing. This is very common feature. We also call it as intermedullary pinning for these type of the veterinary patient. So intermedullary pin is passed through the intermedullary cavity of the bone for repairing the fracture. So this is an intermedullary pin which is basically put into the intermedullary canal, right? So just for the understanding of some of the readers, normally these type of the bones are hollow from inside. Only here I am having a spongy type section, and in the down I am having a spongy type section. So in between, basically this is a hollow. So as a commercial practice, we basically insert the intermedullary pin over here. So usually a simple intermedullary pin is not suggested to long bone fracture in dogs because of unstable configuration. And once just imagine this is the leg of the front leg of the dog, right? So I have put some intermedullary pin from the top to the bottom side. So upper part is called proximal, the lower end is called distal. So from the proximal to distal, basically I have inserted a intermodular pin. So once we do this, now just imagine the dog is galloping. So once it is making a jump, right? So what will happen? The pin that has been inserted from the top, because of the load, because of the compressive load, it may comes out from the other side, right? So it can be a situation where the pin has been pierced from the other side. So that is really painful, and a lot of surgical implications are there, right? To solve this problem, people are working on the improvement of these type of the intermedullary pins. So for the long bone fracture, the intermedullary pin is not a very good solution, because it may not be good in case of the some compressive load, and once we have some rotational stability, and these fractures can be unstable, uh, specifically if I am using a static or rigid fixation technique. So people are working on bone plating, intermedullary interlocking nails, but the problem is with these type of the solutions, we are not following the principle of biological osteosynthesis. So osteosynthesis is emphasizing on a fixture fixation should be attempted in a minimal invasive fashion, so that the soft tissues basically, to what extent we can preserve them, they should be preserved at the fracture site. So osteosynthesis is a complex process, specifically for the canine long bones, as it requires the knowledge of biomechanical principle, biology, and surgical techniques. People have reported that the bone plates have a better success rate to the tune of 91% as compared to the intermodular pinning, where the success rate is 64%. Right, but it has some advantage that it is helping in osteosynthesis, right? So intermodular pin provides less destruction to the soft tissues. We have less rigid fixation techniques in intermodular pinning. Bridging plate can help us in this way. It has been reported that in case of the mandibular condylar fracture, titanium-based intermodular implants will be having more strength and stiffness than the mini plates. And the end-threaded pin, that is one of the solution that we have used in this case study, is the modification of the Steeman pin that is actually used commercially in these type of case. Now, this threaded portion in the end threaded pin provides the better holding of the pin in the distal end of the bone. Like I have shown from the top, we are inserting a pin. So when it is going to the distal end, so basically it is helping me in, having better stability, right? So intermodularly fully threaded pins provides good rotational stability if it is provided on the distal end as well as on the proximal end. So unthreaded pins can be modified with different threads. People are working on the positive threads on the various thread profiles like V, U, and then they're working on the square threads. And positive threads can be used in the proximal end for the battle holding, and it may increase the retention rate. Now again, the similar way we try to see on the Wasware, and this is open source software, and we try to see what sort of a work has been done in the area of intermodular pin, and we came to know that as regard to the intermodular pin, very little work has been reported as connected to the different knee joints, then for child case, then plate fixation. So since there is no link, so no work has been reported. There is a lot of potential to do in this area. So based upon this, we tried in a way based on our own methodology. So selection of the subject, the patient was selected. Then the CAD modeling of the innovative intermodular pin profile. I am interested in typical design of the intermodular cavity. Then because you are going to put this part inside the body of the patient, so what we need to know is take the yes from the basically veterinary patient. So for that purpose, the thermoplastic print was first printed just for the demonstration, and after the pin profile was selected by the surgeon, we printed it on a metal printer. So on a metal printer, we have some of the parameters like laser power, scanning speed, layer thickness that we can basically optimize. And in this case study, we have used the DMLS, that is direct metal laser sintering, as one of the process for development of these type of the intermodular pins. And finally, measuring their hardness, surface roughness, dimensional accuracy, and then the process parametric optimization. So these are the various stages: selection of the subject, CAD modeling, then preparing some ABS printed intermodular pins just for the demonstration, profile verification by surgeon, selection of the material. In this particular case, stainless steel 174 pH was used. Then printing of the selected intermodular pins on DMLS, then measurement of some mechanical properties followed by process parametric optimization. Now this is the exact dimension of that pit bull, and you can see on the proximal end and the distal end. Here is the bone structure is something like this, and for the different parts, I am having the exact dimension. So this is the first stage of preparing a uh, different type of the threads. Basic idea is, if I have shown you the structure of the bone, inside it is hollow, but on the ends, means at the proximal and the distal end, it has a sponge type structure. So in one of the example, yeah, am I audible, please? Am I audible? Am I audible?
Ah, yes, sir. Your presentation and voice also audible, sir.
Okay, great.
Both are correct.
Okay. So in this case, what you can see on the proximal end and distal end, we tried with the different pin profiles. So in one of the example, in case one, the threaded portion is here only. Then in second case, some thread is here and some threads are here. And in third case, this is a uh, very long thread. Basically, the idea is for these type of intermodular pins that we are using in preserving the heart tissues. The length may varies from let us say 15 centimeter to 22 centimeters. So we provide a solution in which I have a long threaded region. So up to the length it is required, we insert, and rest basically that is being cut by the surgeon in the surgery as per the requirements. So in the first case, the thermoplastic based pins were printed on this FDM printer. This is basically a U print, US based printer, and using this Once we get a okay with the surgeon, so we printed the different pins on a metal 3D printer. So this is the final design that has been approved in our case by the surgeon. So the diameter, there is one another important thing here is, so once I am inserting the pins, let us say from here to this side, here the inside cavity over here, as a thumb rule, the 70% of the dia reduction is there. So that we have to really see. So once I am reducing this area again from here to here, because I have to insert the pin here, the 70% dia is only available. So accordingly, we select the dimension. So here in this case, 150 length pin was printed. We selected some of the threads over here. Like for the V thread, the pitch was selected. Then the dia of these type of the pins were there, and we used the fabrication on the direct metal laser sintering and prepare these type of the intermodular pins. So we use the 174 pH stainless steel. STL file was there, inclined wall support with some laser power, scanning speed, and layer thickness was used. So again, for the metal printing, you have the selection of the material. You have the once we get a material, normally as a commercial package, we have a nickel based alloy. Then we have titanium 6Al4V, and then we have the stainless steel. But this is an open source machine. Anybody can have a different combination for printing of different biocompatible materials. One limitation is only the fine 20 micron, 30 micron size is the minimum requirement for the powder. So we do the sieving, then preheat treatment, then importing the STL file, then adding sport, slicing, going for the process parameters. Then basically the software helped me to generate a .fab file. This file goes to the printer. That is, in our case, it was of the 3D system. So we load the part, start the inerting process under the inverted environment. Basically, we are printing. Then after successful printing, the build plate was removed, cleaned in the vacuum chamber, post-treatment, removal of the part, and the finishing. This is the basic flow diagram. So again, we can see this. So sieving, some heat treatment. So this is the build platform. This is the DMLS printer. Then some heat treatment. So some pins are there. Some surface roughness measurement, dimensional measurement, and some hardness measurement data has been taken for this type of material. These are some of the parameters like laser power, normally for 100 watt, 120 watt, 140 watts, scanning speed, layer thickness, measuring some parameters like hardness, dimensional accuracy, surface roughness, and dimensional accuracy, going for their signal to noise ratio, and then multi-factor optimization. These type of things as a standard statistical tool we have performed, right? And these are some of the grain structures that we came to know for these type of different settings as regard to the ASTM E112 and ASTM B276 for the grain size number and the porosity. And for all these material, we try to collect these type of these structures. Now, what is important over here is I am interested in preserving the natural, tissues, basically the hard tissues, which is a skin in this case. And for that purpose, I am using a threaded pin, right? So you just imagine the surgeon can insert this type of threaded pin from the proximal end. Once in the X-ray, I am finding in 10 to 12 days there is a total proper bone growth. I can basically remove that part, and the patient is really recovering very fast. So minimum invasive surgery type situation can be there. And we try to correlate the mechanical strength, the morphological property with their grain structure and the porosity part, right? So this is the second case study. Now this is the third case study that I want to discuss specifically in case of the veterinary patient. This is the again on the dog, and we are interested in preparing some of the strategic teeth of the dog and the implants for these type of the dogs. This can be again through the very much used for through the additive manufacturing. Now, this case study on the pre and post processing, we use the FDM platform for preparing the thermoplastic based, crowns, and then we went for the investment casting. This is the one route. The second is directly we can print on a metal printer. Now if you see in this case, this is the upper arc of the jaw, this is the lower arc. So this one is called maxilla, and this is called mandible, right? So there are around 48 teeth. Out of these 48, the four are the strategic teeth in the upper arc and four in the lower arc, right? You can see this is the strategic teeth are, this is the canine, this is the most important. You see, if I see the canine, so it is a long root, teeth is there. So this is the major tooth. These are the incisor. These are not really important in case of the dogs. This canine is really important. And then we have the maxillary premolar 4. So this is in the maxillary premolar 4, right? So as this is the maxilla, this is the mandible, and then I have the mandible, in the mandibular M1, right? So these are really important teeth, right? So 1 2 3 4 on this side and 4 on the other side of the jaw. So total 8 teeth are these are considered as the strategic teeth of the dog. Why strategic? If any of this is lost or there is a damage for these type of PM4 M1 or canine, right, the dog eating habits are compromised, and this will have a serious effect on the health of the dog. Now if you see the information on some DRDO website, or some FBI website, some training to some special dogs is there. These are for the by the narcotic department, people are working on this, and then some defense dogs are there, right? So for these narcotic and defense application, what actually we are interested is, uh, once the dog basically it judges that for there is some issue for this type of uh, what I can say, there is a some, let us say, some antisocial element is there. There is a chance that there can be some drugs in some packet. So what actually dog is doing, they are basically trying to crush it, right, as a natural habit. And these antisocial element, what actually they are doing is, they are having some sort of a titanium shells covered around this. So what will happen, so if there is a sudden bite force which is to the range of 800 newtons, right, so there can be the damage of the canine, there can be the damage to the PM4, there can be damage to the M1. So what these DRDO people or FPI people they are doing, they are providing a outer shell as a coverage to these type of the strategic teeth. So that is the work done in this type of the work, right? So this is under the prosthodontics area. So here we are interested in restoration and maintenance of the missing teeth with some oral structure by the artificial device. This also includes the cosmetic restoration and rehabilitation of occlusions and processes. So if I see the literature, the prosthodontic treatment for veterinary patient, it may have inlays, it may have onlays, partial crowns and implants. Uh, Presently, we are really interested using 3D printing in this area, along with some different areas also. So better clinical care of the orthodontic patient. We have the CAD data. I can use the CAD and CAM for basically having a better fit for various versatile functions for aesthetic looks using different CAD softwares. In case of the dogs, these tools require also a good appearance. They have to perform multifunctions like chewing, tearing. Then it can save them from the external attack. So it has been reported, widely reported in literature. There is a partial or full loss of teeth, right? So this is under the periodontal disease. This is maybe because of sometimes trauma. This may be because of the accumulation of plaque or tartar, resulting in some gum infection, loss of bone, and the spotting structure. So people are working on using some crowns for as a solution for these type of the problems. Now you can see in this picture here, this is the healthy teeth. This is for the German Shepherd dog, right? This is the, left maxillary, and this is the healthy right mandibular canine. This is the, this B is the healthy left maxillary PM4, right? So now you can see on this canine there is a damage. Now once this damage is there, the dog will stop eating, right? Similarly on this, there is a, on the PM4 there is a damage, right? So what we are interested in, using a 3D printing, we are interested to put some cap over here, like you can see over this. So that is the, work that is actually going on in the area of these type of dogs, and we are really interested in putting some of the, metal or the composite crowns for the partial, as a partial denture, for the, basically for the restoration purpose. Again, we use the Web of Science database for developing this type of bibliographic analysis or the networking diagram. So what we came to know, there are different clusters, each cluster representing a different group of people working in this area, right? So this is really important for this type of the printing. So what actually we do, so there are some steps, like in step 1 I have the selection of the subject. So 3-year German Shepherd dog as a was selected, as a then some strategic teeth were selected. So like I have shown, strategic teeth involve canine, PM4, M1. Then in step 2, I am interested in developing a Dinestone model. So under anesthesia, we take a dog impression on the alginate colloidal, then dog biting as on the negative cavity, then dental gypsum stone to get the Dinestone model. Then in next stage, we have the development of the CAD model. So basically, by using a scanner on a Dystone model, then modification of the surface scanning to the 3D model, then virtual copying, and then final CAD model extraction. Then for based upon this CAD model, next stage is obtaining a thermoplastic pattern. So using a CAD model for the strategic teeth, use on FDM printer, removing the sport, getting the master. Then comparison of the dimension, so that can be done with the Dystone model. Then post processing, we can think of different heating cooling cycle below the TG of that material. Then comparison of the hardness, do some sort of optimization, and finally in the optimization state for the printing part, we can do the different type of optimizations, right? So in this case, you can see that this is a dental tray over which we are taking this type of the impression. So this is an alginate, this is the impression that is there after the dog bite. So these are the Dystone model that you are seeing for the different type of, here this is for the canine, this is for the premolar, this is for the molar, right? Now here is a Dyson model that has been prepared, and 3D scanning using this, using scanning software. Basically the STL CAD file has been generated. So once I have a CAD file, so I will just own the FDM machine, import that CAD file. I can select the density of the part, the number of parts to be printed. I can do the scaling, then orientation, then again the slicing, number of files by cross-checking the build platform, and then clicking the print command, then the volume and the model of the sport. Then we can estimate the number of layers, check the print option. Printing will start once you have a chamber temperature ranging from 75 to 80. Then estimating the finish time, number of layers, these type of things will be there. Then after successful printing, we will be removing the sport, and then finally cleaning and uploading for the further processing. So these are some of the crown angles that we can basically control, and these are the different printing stages. And finally, by using some DOE, I can think of printing these type of the crowns. Now these crowns can be printed through the polymer printing and then go for the investment casting, or in the second case, these crowns can be directly printed on a DMLS printer, that the way I have shown in my previous example. Then for all these polymer printers, you can see, as this is 3D printing, the staircase effect is there. So we got the same image, and then their 3D rendering. and their surface roughness, because this is going to affect the final finish of the investment casting part also. So we can control this in a typical 3D printing application. Till now, we have covered some of the things for veterinary. Now, in this is the another case in case of the human dentistry. Now, here again for the hard tissue printing, we can think of using the nano HAP, and we can use FDM assisted investment casting for printing this type of material. So what actually we did is we have collected the eggshells. So basically, the eggshell is a very good source of nano-based HAP particles. It is reported that the this hydroxyapatite, that is HAP, it consists of 96% similar composition as that of the human teeth. So basically, we do the we collected the eggshell, which is basically a kitchen waste, then crushed those eggshell in a cryogenic environment and prepared our own nano-based, HAP materials, which was reinforced with ABS. And once it was reinforced, we prepare our own feedstock filament for the FDM, and prepared the final patterns, master patterns, and then we did the investment casting. I can think of putting the investment casting of nickel based alloys. And now this is once I am going in the stage of the investment casting, so I have to basically remove the ABS by hitting to the range of 1100 degree Celsius temperature. So what will happen, the HAP particles, which are basically a ceramic particles, they will be there, and once I will put the molten metal into this, I will get a metal matrix composite. So that is what I am calling it as a FDM assisted investment casting approach for preparing of the dental crowns. So that has been used in this case. We can think of using a cobalt chromium based alloy or nickel chromium based alloy, and that can be used for preparing a partial or the complete dentures. So these are some of the historical things about the partial dentures or complete dentures. It has been reported that in 7th century BC, people have worked on in Italy for the development of these type of dentures. Then in 16th century, people have reported in Japan use of the wooden dentures, and then in one of the paper by Donaldson, it has been reported that people used even animal tooth for preparing the dentures. Then in 1820, as per the report, people have used 18 karat gold for preparation of the teeth. And then vulcanite rubber has been reported. And in 20th century, as per the paper of Adam, people have reported use of the thermoplastics also for this type of printing. In one of the paper by Torabi, it has been reported that since 80s people are using CAD CAM, then dentures for the removable type or non-removable type, a lot of things have been there for the mandibular as well as the maxillary arc. So dentures can be removable for humans, and it can be partial non-removable also. Then it can be complete or it can be the partial denture. Like you can see in this case, this is some part is there, so some part is missing. So this is an example of the partial denture, right? So that can be actually one of the interest area for some of us. So if I talk about the use of additive manufacturing, I need a digitalization tool for the CAD/CAM data. So I need a software which can process the scan data, then manufacturing technology for printing these type of the parts, right? Then CAD/CAM system can be really used, and finally these sophisticated NC machines like milling or subtractive or additive manufacturing I can think of. So this comparative chart will be more clear with us. I have the teeth model. I can have a CT scan data. Then I can think of generation of the CAD file, right? And then verification of the CAD file by free form. Then I can think of using a NC or CNC machine for the development of the denture. Then there can be another way. Again, you have a CAD file. Again, verification of the data in not in now. I'm not interested in subtractive manufacturing. I'm interested in additive manufacturing, right? And then the third case, the traditional one, manual wax model and the investment casting. So all three techniques are quite common for the simple cases. The traditional wax models are very common. Commercially in the country like India, this subtractive based investment casting for using NCCNC is also there. This is also one form of the prototyping, but for the complex cases, of course, the additive manufacturing is only the solution, right? So how to do this? I have a, I already explained that we basically need to measure the rheology. So we used to find out the MFI of that material. So how it actually works? So I have a, system like this. I have a cavity, I put material over here, then this piston moves down, I have a weight, I have a die in this side, and I have a temperature control. So this is the temperature. This is the, pin that is pushing, and this is basically a plunger. I can add the load. So some wire that is being prepared. So how much gram of wire in 10 minutes that comes out of this is called the MFI of that material. So as the MFI is high, basically I can prepare the thin section. Like in this particular case, we were interested in reinforcement of the, you know. Uh, these abrasives, that is the ceramic particles, that is the nano have particles, right, into the ABS matrix, because basically I am going to lost wax type process. So I can think of non biocompatible also, because finally I'm going to use this as a quaternary recycling process, so this can be used, right? So MFI was ascertained, and then the extrusion for preparing this type of the feedstock filament, and then some printing going on. So you can see these type of the dental processes have been prepared. So I think I have discussed all these observations. Now, the in the last case study, this is for preparation of some implants. This is the hip implants. In one of the recent case, we try to prepare these type of implants for the Labre dog. This is the case for the human. You can see in this case there are the different sizes. This is for the 6 feet long male. Different design for the hip implant has been there. Then, like a typical investment casting application, we are interested in down sprue. This is the pouring basin, this is the down sprue, right? So then some connections in the form of runners, right, and ingates, those has been prepared, and this has been joined with this, right? Now this is the, putting the wax layer, right, then putting the slurry layers. So slurry layer is there, so you can see over here. Then I am interested in the dewaxing stage. So basically after dewaxing, so I am putting the molten metal. So once the molten metal is poured, so I am available with the different stainless steel, basically 316L has been prepared as a hip implant. This is very common thing. But one of the limitation of using this type of material is like the these type of the implant materials, once I prepare through investment casting, which is assisted by some FDM, or I'm using a metal printer, or I'm using a biogel printing. One of the limitation is the part finally that I prepared is having a strength much more than the basic strength of the bone, right? So there is a, basically incompatibility as regard to the strength part is concerned. So there is a problem of stress concentration, right? So we call it as a stress shielding. So for that purpose, one of the solution is to prepare a, hollow section or the perforated section through which some osteoblast cells can grow and can help in the stress shielding. So that is one of the best way of preparing these type of materials. So then some microstructure analysis has been done. So using optical microscope, that under different settings that we prepared, there should not be dendrite formation, there should not be quick grain formation. As far as possible, the cooling rate, these type of collaboration calculations were there, so that I can get a honeycomb type structure. So this is all about the preparation of the various implants for the veterinary as well as the human patients. Now I think I'm open for any discussion. If there are any queries, I would really like to answer those queries. Under Atmanirbhar, this is one of the upcoming area where we can prepare our own implants. We can prepare our own heart tissues. Uh, you will be surprised if for hip replacement or knee replacement, I am going for human case, that is available. Some joint is available to the tune of 50,000, right, as a commercial implant. But if I am interested in getting these type of implants for dogs, these are not prepared commercially in India, so this cost me sometimes 2.5 lakhs. So that is one of the area where we can think of a startup and can support these type of the veterinary patient, specifically those who are interested in the research component part. This can be help in a way that if I'm developing this thing for the veterinary patient, we get relatively good clearances from various regulatory body, because once you have to put in human, or in case these type of the dogs or any other animals, we can think of so much regulations. But in case of the veterinary, the relatively the ethical committee clearances are much liberal as compared to a human case. So this is I think one of the upcoming area, and relatively less competitive as compared to the humans, and less risky also. And definitely in a state like country like India, and specifically in this region, Punjab side, we are really interested in health of the animals, because this dairy farming is really very good business in this part of the country. And to help these type of the bovines or canine, this can be really a good in sporting NEP 2020, and in developing our own implants for Atmanirbhar Bharat. All right. Okay, there is one query by someone. They are asking for kindly share if any new material developed for human tooth other than titanium 6Al4V and zirconia. You see, what we can actually do is, let us understand first the difference of implant, and some processes over there. If some part is deep inside the body, that is considered as an implant. And specifically, if I am interested in an implant, we are interested in biocompatible material, and the titanium 6Al4V is one of the best solution. And then the second most common, second best is the stainless steel 316L, right? But if you are interested in crowns, the crowns can be of different materials. Even after preparing it with stainless steel, people are doing zirconia coating, different type of coatings, right? And here the important thing is, if I am interested in developing those implants, in place of importing those implants, I can think of developing those implants by 3D printing. So that can be really useful idea in investing so much money of the country for very expensive machines. Like the DMLS we are working on, this is around 2.5 crore in our place. And if I am again importing the implants from the Western world, then there is no fun of investing in such high end machines. So my submission is, along with the material part, the design and the fabrication for the some integrated component is really is going to help to us. So I think your question is answered. We can work on stainless steel, we can work on cobalt chromium, we can work on nickel based alloys, specifically for the dentistry application. Okay, any other, please? Is there any other question? Okay, so somebody is asking about the improving the dimensional accuracy in printing. So dimensional accuracy in printing is a general purpose thing. As regard to the dimensional accuracy, I am I need to understand whether I am interested in polymer part. If yes, then in case of the polymer part, we have a real problem of the staircasing effect. So to have the solution for the staircase effect, basically we are asking about the post treatment. And in post treatment, one of the best solution is using a chemical treatment. Like for example, if you are working on ABS, then give a exposure to the acetone for a few seconds. Then after the exposure of the acetone, you can basically make a nano level finish for in few seconds, just 2 to 3 seconds. Then people have also reported the use of temperature, like putting the material below TG. This also helps in improving the dimensional accuracy. As regard to the metal printing is concerned, the accuracy is not a problem because we are getting a high accuracy to the tune of 20 microns. Here in that case, the very fine size powder preparation is a issue. As regard to the biogel printing, the accuracy is really good, and we get very precision results. But in any case, if the dimensional stability is a question, the post treatment is probably the answer for that type of the situations. Right? Okay. Any other, please? Do we have any other query? Okay. So if there are no more queries, I would like to thank the organizers for giving me this opportunity to be the part of this FTP. Dr. Shankar Narayanji, thank you very much for this opportunity. And I hope the idea is clear to everyone. Anyway, if there will be further queries, you can just drop a mail to me. I would like to answer those queries. With this, I thank you all.